Oh man. Well, hello everybody. I think that I'm all set up here. Alright, good, I am all set up. So, this is a review for the evolution quiz. By the way, if anybody from my period 7 shows up, I told you to let me check at home, see if I had your stuff, and I do. Some of you were panicking and freaking out for no reason. Alright, so let me go through some of this review sheet here. This might be slightly different. Excuse me. This might be slightly different from the review sheet that Period 1 and Period 3 have. But I think most of it is very similar, if not the same. And if you have specific questions from the review sheet that you've got, let me know. One of the big differences between these two review sheets is this was not on the review sheet. So, I mean, this is not on this particular version of the review sheet, but it is on the one that the Period 1 and 3 classes got. So, and it's probably the hardest question. A little more thought involved. 4 female mice in a beach area. Color of the area, tan sand. Which mouse would likely be the fittest, which means which mouse would survive the best, basically. Explain why the mouse would be fittest. Also, fill in the blanks with numbers that make sense. So, number of pups made. Let's see. We've got to consider some things. Number 1, let's consider the color of the fur. Number 2, let's consider how long the mouse lives. Number 3, let's consider how fast it could run away. So, will it stand out and get eaten? Is it fast enough to run away? Well, how do you know? That's kind of arbitrary. What if the speed makes up for the color issue? Because black is going to stand out in a tan environment. Well, we get our answer right here. Age of death, 2 months. And you could see the cream colored and the black colored are by far the worst in terms of surviving. So the speed is not enough to make up for how much it stands out. We'll come back to filling this out in a moment. We have creams, 2 months. You would think cream color might do okay blending in with tan sand, but look at how slow it is. So sticks out a little bit, and it can't run away. Then you got the tan and black. It blends in a little bit, and it's got some speed to it. 4 months it could live, so that's better than the cream and the black color. But then tan blends in. He's got okay running speed and lives the longest at 8 months. So when you fill in your pup numbers, it's relative. Who do you think should have the least amount of pups, for example? Who do you think is going to survive the least? So that mouse is the one that you would give the lowest number to. In this case, I think we have a tie, don't we? Because they both only live for 2 months. So these two should have probably your lowest number for survival. So, maybe 1 pup and 1 pup. Tan and black survives a little bit better, so maybe 2 pups. And tan survives the best, twice as long, so maybe 3 or 4 pups. Right? It's arbitrary numbers. The numbers aren't, like the specific numbers you choose are not important. What is important is that your numbers make sense relative to the survivability of each mouse. So, interesting little puzzle question kind of there. Right? Natural selection, done a ton on natural selection. If you got the best trait, you're probably going to survive the longest. If you're the biggest, Excuse me. If you're the strongest and the fastest, then you probably have the best traits. And you'll probably get more food than others can, which will help you be more likely to survive and pass your strength and speed on to the next generation. Until eventually, only the strongest and fastest will survive. That's one example. You do coloring. Perhaps this environment over here was not tan. Perhaps it used to be muddy and dark. And so the black colored mouse maybe used to live the longest. But the environment changed to more tan, and there was a mutation one day. We got a tan mouse. That mouse was able to hide, live the longest, and eventually more and more tan mice survived until the environment was mostly tan mice. So those are examples of natural selection. Nature picks the best trait. Artificial is easy. Just think of people breeding horses for horse racing. Only the fastest horses are allowed. So artificial is when humans select the traits and the animals that get to breed. How are these bones evidence for evolution? Well, fossils in general. It's two ways. First of all, evolution is change over time, right? Evolution equals change over time. All organisms, all living things, share a common ancestor at some point. So at some point, if you go back far enough, there's one animal that all of us have in common. Human, whale, cat. We all have one particular animal in common if you go back far enough. We're talking hundreds of millions of years. So you got to go back quite a ways. And yet, even though we all started from that one animal, and that animal had its own ancestor that it came from, so it's not even like that was the first animal ever. It's just that that's the animal we all share in common, all of us mammals. So, even though we all came from that animal, clearly there have been some changes over time and some pretty big differences over time. So, how are these bones evidence for evolution? Well, they show you the differences that arise in organisms that separate us from each other and our common ancestor. They show that we have changed our features since then. They also show certain similarities. You can see right here, look at the template. One bone for all of us. Two forearm bones for all of us. Little wrist bones. That's right, whales have little wrist bones. And finger bones. We all have that in common. So fossils also show similarities that can be inherited from a common ancestor all those ages ago. So it's both. You definitely want to know how DNA and fossils and whatnot can provide evidence for evolution. Definitely important. Oh, I gotta change the title. I have genetics test review as the title. So this is evolution quiz review. Okay. Okay. Adaptations, and I believe what's more is I gave an example of this earlier with the mouse color, where the environment had changed, there was some kind of mutation, so you ended up with a tan mouse that blended in very well. That mouse survived the most. It had a competitive advantage which helped it live and reproduce more, and eventually it reproduced more than the other colors to such a degree that the population was dominated by mostly tan mice. So that's how any trait really is going to evolve in a nutshell. An environmental or genetic change, a competitive advantage, population with that trait grows more and more. So it's kind of a three-step thing, as far as we're breaking it down, kind of a three-step thing. You can name other adaptations like sharp teeth. The organism with the sharper teeth could rip into food more easily and chew food more easily, which helped it survive and save energy, and or maybe rip open its prey's belly so the prey bled out and it was easier to hunt because of the sharp teeth. You could go in a couple different directions, but the key is, those three steps you could apply to any trait. Environmental or genetic change leads to a competitive advantage, and eventually that population with that trait will grow. So that kind of builds off that question. Genetic change, that's a new variation going to show up. Mutations, for instance. Kind of just went over this. Mutation, maybe, leads to the first large beak. That large beak is better able to secure maybe the food on the island. Maybe it could break open coconuts or crab shells, and the small beaks can't really do that as easily. And then they grow in number, and they have a competitive advantage because they can eat more, and they just start taking over more and more space and drive out the smaller sized beaks. So mutation, advantage, and population growth with that one trait. Okay. Okay. So we kind of talked about this with the fossils earlier. So we talked about that with those. They can show the differences. Even though we all started from the same ancestor, clearly we're all different. You could see those physical differences here. So it shows that change over time has occurred. And it also shows the similarities from the common ancestors. Embryos are much the same way. They show a lot of structural similarities. And they also show a little bit of key differences. But big thing is we look so similar when we're embryos, which is evidence that our basic embryo genes are inherited from a common ancestor, which is why we look so similar, because those genes we have that are responsible for us as an embryo, those genes are shared from that common ancestor. And so that's why we all look very similar. Example of evolution from great transformations, you could talk about the whale fossil, you could talk about, which is similar to the fossil thing that I was talking about earlier. You could talk about DNA and the fly genetics. They were able to take the gene for a mouse's eyeball, and they stuck it in a fly, and the fly was able to grow fly eyeballs with a mouse's gene, because the mouse gene and the fly gene are inherited from a common ancestor. So the two genes are so similar that the mouse gene was able to work with the other genes inside of the fly and come up with a correct compound fly eyeball. But if they didn't have that common ancestor for that particular trait, if they didn't share that particular gene, I should say, or if there had been too much genetic change over these hundreds of millions of years, then obviously that wouldn't have been possible. But it shows that not every trait is from a common ancestor, but there are plenty of genes and traits that can show. And this mouse and the fly eye example is one example showing that we do have those similarities. So I think that's about it. I had to do this a little bit earlier because, as you could hear from my incessant yawning, I'm just a little bit wiped at the moment. So I figured I would get this done and out of the way, so at least it's sitting here for people who may need it. And if anybody has a question, leave it in the comments below, and I will Try to check it a little bit later tonight, and if there's enough questions or whatever, or if the question's complicated enough, then maybe I'll jump on and I'll just do another quick one, and hopefully you'll get a notification about that when I do. So, hope this helped. Good luck on the quiz, and that's it. Peace out.